Alright, in this video we're going to take a look at the even and odd powers of x minus c theorem and how we can use the exponents that are on our factors of our polynomial to help us figure out how the graph behaves around the x-intercepts. Now the first thing that I want to tell you is that even and odd powers of x minus c theorem is just very simply the multiplicity of the factor or of the zero or of the x-intercept that you are talking about. What multiplicity is it's the number of times a particular value shows up in the list of zeros, or a particular point shows up in the list of x-intercepts, for example. Now you might be wondering what that has to do with the power on a particular factor of a polynomial. So let me kind of show you how these two things are connected. Let's say that we've got a function. F of x is equal to x minus 2 times x plus 3 squared times x minus 1 cubed. Okay? Now, let's talk about what these exponents mean. The exponent that's right here is understood to be 1. Okay? This exponent is a 2 and this one is a 3. So what that's telling me, remember exponentials are shorthand multiplication. This is telling me that I've actually got x plus 3 times x plus 3. And then here I'm going to have x minus 1 times itself 3 times. Okay? So if we laid the whole thing out, if I've got room for this maybe, x minus 2 times x plus 3 times x plus 3, there's the 2 of those, okay, times x minus 1, x minus 1, x minus 1. There's the 3 of those. So in actuality, we've got 1, 2, 3, 4, 5, 6 total factors, okay? This particular factorization comes from a degree 6 polynomial. Now, it's not degree 6 just because there's 6 factors, okay? It is possible to have 6 factors and it not be degree 6. It could be degree 7, depending on whether your factors are linear or not. But that does mean that we do have 6 factors. So from those factors, we're going to get, since they're all linear, 1, 0 each. Okay? So from the first one, I would have x is 2. And then I'm going to get x is 3 twice. Whoops. Hang on a second. Erase that. Right? Because I've got 2 separate factors that are that same thing. And then x equals 1. Those are supposed to be negative 3, sorry. X equals 1 is going to happen 3 times. Okay, so in this group, that's a multiplicity of 3. That's a multiplicity of 2. And this is just multiplicity 1, which is called a simple 0. Okay, now, the 2 and the 3 can just be read from the power. You don't literally have to write both of these out or all 3 of these out and solve them separately. You can get that multiplicity just from the power that's on the factor instead of dealing with writing it completely out. Okay, so that's what the power on the factor and the multiplicity have in common. They're the same thing. The power gives you the multiplicity. If you don't have an exponent, but you do have more than one of the same factor listed, you just simply count like we did here, 1, 2, and that will give you your multiplicity instead, okay? Now, let's talk about what that tells us about the x-intercepts that come from those factors. If the multiplicity is odd, the graph will cross through the x-axis at that intercept. Now, this is really what we think of happening when we think of x-intercepts, okay? Let's say our x-intercept's right here. You've got your graph, and what it would do is actually cross through the axis at that point. Okay, so if your multiplicity is odd, this is what's going to happen. It may curve through it rather than being a straight line, but it's going to go through the axis. All right, and if the multiplicity is even, the graph will touch the x but not cross it. Okay, so again, let's say that we've got this x-intercept. The graph will come in. Sorry, I can't see under my finger as I'm graphing this. Let me try with a stylus, see if I can do it a little bit better with it. The graph will come in, go through the point and bounce off, essentially. It looks like a bouncing ball that you've bounced off the floor, or if it's underneath, it'll look like it's been bounced off the ceiling. So it's like the x-axis just sort of repels it once it hits it. So if your multiplicity is even, if you've got a square or fourth degree, then this is what's going to happen at your x-intercept. Okay, it's going to touch but not cross. So now let's look at a couple of problems and identify the 0, the x-intercept, what multiplicity is, and whether it touches or crosses. Okay, find the zero's x-intercept's multiplicity and whether it touches or crosses the x-axis. All right, this is our little function, and we've got 3 different factors. Let me add an exponent right there, just so we've got another one to look at. This time we will have zeros. We will have the x-intercept. We'll have the multiplicity, and we'll have whether it touches or crosses the axis in our little table, okay? All right, so the first thing to do is find the 0 from each one of those factors, okay? So looking at this one, set this one equal to 0, solve for x, see what you get. Should be getting a -2. Then the x-intercept will be -2, 0. Multiplicity, that comes from the exponent. So what is that? That's 2. And then if we touch or cross, that goes back to our rule about if the exponent is even, we are going to, or the graph is going to touch the x-axis at that particular intercept. So touch, you can just use a T if you want to identify that. Now move on to your second factor right here. Set that equal to 0. Solve it for x. And we get a 1. So 1, 0 is the x-intercept. Multiplicity is 1. Odd multiplicity means that we cross. And our last one. Set that equal to 0. X minus 8 equals 0 gives you, x plus 8 equals 0 gives you a -8. -8, 0 is your x-intercept. Multiplicity is 3 this time, you see up here. And that means we cross there again. Okay, now when we get to graphing these, we will we'll look at how we put all of that together, and we use this along with the end behavior to kind of feed the line, which makes up the graph through the points that we have established. In addition to the zeros that you find here with the x-intercepts, you'll also want to look for y-intercepts. That'll be something that we'll do on our list. And there'll be a couple other things that we'll look at too to get a couple more points. We'll probably plot some points if we need some. May not. If we have enough x-intercepts along with our y-intercept, we probably will have enough stuff. But that's where we're headed next, is into the graphing.